Hello everyone, welcome to this channel. In today's video, we are going to be looking at binomial expansion. In mathematics, a binomial expansion is the process of expanding an expression that is in the form a plus b raised to the power of n. So in this video, we are going to categorically consider two processes. The first is the binomial expansion formula, and the second is Pascal's triangle. The binomial expansion formula is given as sigma n r equals 0 in parentheses n choosing r. A raised to the power of n minus r, b raised to the power of r. So in this formula, this Greek word is called sigma, and it is spelled sigma, which means sum or add up, and the arrow represents the power or index from 0 to n, where n choose arrow is given as n factorial all over arrow factorial in parentheses n minus arrow factorial. Alright, so let's consider this example on the board. Suppose we have in parentheses x plus y raised to the power of 5. Using the concept of binomial expansion and the established formula, we can therefore write this or solve this as x raised to the power of 5. The first term in parentheses always begins with the highest power or with the power with which the parenthesis is raised to. Therefore, x raised to the power of 5, and the second term in the bracket begins with 0. As the power of the first term, x, decreases, the power of the second term, y, increases. Therefore, that of x will decrease that of x will decrease from 5 to 4, 4 to 3, 3 to 2, 2 to 1, and gets to 0. Whereas the power or the index of the second term, y, will increase from 0 to 1, 1 to 2, 3, 4, and it will get to 5. Therefore, this is the first term. Second term plus x, it will decrease from this to 4. Why that of y will increase from 0 to 1 plus x again will decrease from 4 to 3, and y increase from 1 to 2 plus x to 2 and y to 3 increases to 3 plus x from 2 to 1, y from 3 to 4 plus x from 1 to 0 and y from 4 to 5. As the power of the first term decreases, that of the second term increases. Therefore, we have x raised to the power of 5, anything raised to the power of 0 is 1, Therefore, 1 times 5, x raised to the power 5 is x. Let's say the y variable will be omitted. Plus x raised to the power of 4 y plus x cubed y squared plus x squared y cubed plus x y raised to the power of 4 and plus anything raised to the power of 0 is 1 and 1 times y raised to the power of 5 is y raised to the power of 5. This is the first step. In binomial expansion, the first step is the expansion of the problem given, whereas the second step is the application of Pascal's triangle. Pascal triangles, when the coefficient is 1, when the power is 0, then the binomial coefficient is always 1. When the power or the index is 1, the coefficient is always 1 and 1. Therefore, I'll bring down my 1 again. 1 plus 1 gives me 2. I'll write my 1 again. Again, I'll write 1. 1 plus 2 gives 3. 2 plus 1 gives 3. Then I'll put down my 1. Always ensure it is shielded by 1. Again, I'll write my 1. 1 times 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Then I'll put down my 1. Again, 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. And 4 plus 1 is 5. Again, we have 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. And 1 plus 5 is 6. Again, we have 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21. 6 plus 1 is 7, then 1. Alright, let's do the last one. 1 plus 7 is 8. 7 plus 21 is 28. 21 plus 35 is 56. 35 plus 35 is 70. 35 plus 21 is 20. 35 plus 21 is 56. 21 plus 7 is 28. 7 plus 1 is 8, then 1. So from the first number written is when a bracket, example a plus b, is raised to the power of 0. The coefficient is always 1. From this is when the bracket is a plus b raised to the power of 1. That of this, when it is a plus b raised to the power of 2. This, when it is a plus b raised to the power of 3. Why this, when it is a plus b raised to the power of 4, and this line, when it is a plus b raised to the power of 5, this line, when it is a plus b raised to the power of 6, this line, when it is a plus b raised to the power of 7, and this line when it is a plus b raised to the power of 8. Now take note, when after 1, when the first number is 8, then the index is always 8. When the first value or number is 7, the index is always 7. When it is 6, when it begins with 6, the index is 6. When it begins with 5, the index is 5. When it begins with 4, the index is 4. When it begins with 3, the index is 3. But on the board, we have the highest power, or the power of the parentheses as 5. That is raised to the power of 5, and we are going to use this. We are going to use this as the respective coefficient for this. Alright, let's continue. The coefficient there is 1, x raised to the power of 5, plus, we have 5x raised to the power of 4, y, plus, we have 10x raised to the power of 3, y raised to the power of 2, plus, we have 10 again, 10x squared, y cubed, plus, we have 5x y raised to the power of 4, plus, we have 1 y raised to the power of 5. So we have 1 times this is x raised to the power of 5, plus 5x raised to the power of 4, y raised to the power of 1, plus 10x cubed, y squared, plus 10x squared, y cubed, plus 5x y raised to the power of 4 plus y raised to the power of 5, which is the final result. Alright, let's consider another example when the sign in between the two quantities or the two variables is negative. Example, in parentheses, x minus y raised to the power of 5 raised to the power of 6 raised to the power of 6. Alright, at this point, the sign in between the two letters or the two variables is minus. How do we solve this? When the sign is minus, the expression becomes x raised to the power of 6 and y raised to the power of 0. X, the first variable, the first term, begins with 6 and decreases down to 0, whereas the second variable y begins with 0 and increases to 6. And we have plus x raised to the power of 5 from 6 to 5 and y from 0 to 1. I beg your pardon. This is minus, positive, negative, then positive, another will be negative. So x from 5 to 4 and y from 1 to 2. Here is positive, here will be negative. X from 4 to 3 and y from 2 to 3 plus x from 3 to 2 and y from 3 to 4 minus x plus from 2 to 1 and y from 4 to 5 plus x from 1 to 0 and y from 5 to 6. And we have x raised to the power of 6, y raised to the power of 0 is 1, and 1 times this gives x raised to the power of 6 minus x raised to the power of 5 and y raised to the power of 1 plus x raised to the power of 4 and y raised to the power of 2 minus x raised to the power of 3, y raised to the power of 3 plus x raised to the power of 2, y raised to the power of 4 minus x raised to the power of 1, which is x, and y raised to the power of 5 plus, at this point, x raised to the power of 0 is 1, and 1 times 5 to the power of 6 gives y raised to the power of 6. Y raised to the power of 6. Therefore, using the binomial coefficient, using the coefficient from this binomial, from this Pascal's triangle, this is called Pascal's triangle. This is Pascal's triangle. So let's get the coefficients done. Since the power to the parentheses is 6, therefore this is the right coefficient, the one that begins with 6 after 1. So using the coefficient, the first time there is x, to be 1x raised to the power of 6 minus the next there is 6x raised to the power of 5 y plus next is 15x raised to the power of 4 y raised to the power of 2 minus 20x raised to the power of 3 y raised to the power of 3 plus the next is 15x squared y raised to the power of 4 minus next is 6x y raised to the power of 5 and plus 1 y raised to the power of 6. So this becomes 1 times this gives x raised to the power of 6 minus 6x raised to the power of 5 y plus 15x raised to the power of 4 y squared minus 20x cubed y cubed plus 15x squared y raised to the power of 4 minus 6x y raised to the power of 5 and plus y raised to the power of 6. Observation when the sign is negative is that it will move from positive to negative, positive, negative, positive, negative, positive. So that is how it works. When the sign in between the two variables is minus, but if the sign is positive, is plus there, every time we have a positive sign. So positive, the first is positive, this is plus, this is plus, this is plus, and the next will be negative, positive, negative, positive, negative, and so on. This is very simple. Now let's consider another example that is quite different. That is to say, an example with a coefficient assigned to both variables. A coefficient assigned to both variables. Let's check. Alright, let's consider this example on the board. This is quite different from the preceding example. that we did. In this example, there is a